Engineering is changing our lives, and it will continue to take this role in the future. Technology is making tremendous progress and the world is globalizing. Also, more and more people have realized the importance of sustainability. At the same time, engineering is also being changed as our world changes. As a result, engineering education should find its way to prepare qualified engineers for the future. Moore's law is an example of the exponential progress of technology. It describes that the number of transistors placed on an integrated circuit doubles approximately every 2 years. Nanotechnology has realized the manipulation of molecules and even atoms at nanometer scale. What you see on the screen is that the atoms are being transferred using an atom force microscopy. Biotechnology is also making significant progress. Biomolecules such as DNA are now being used to create smart materials for various applications. Great findings start from the merge of multiple disciplines. In the age of technology explosion, multidisciplinary projects will play more and more important roles in the future. For example, tissue engineering aims to generate human organs for replacing failed patients' organs. Materials engineers contribute to biomaterials, while bioengineers test the biomaterials on animals and human cells outside human body. And then, the doctors implant the artificial tissues into the patient's body. The multidisciplinary world is accomplished by the collaboration of materials engineers, bioengineers, and doctors. How can engineering education prepare students' success for the future multidisciplinary environment? To surpass current engineering students, future engineering students must not only be equipped with deeper knowledge on a specific area, but also be prepared to work in multidisciplinary teams. Engineering education can prepare engineering students with solid foundation of math, physics, chemistry, and biology. Engineering education can also provide them the opportunity to work on multidisciplinary projects at an early time of their career. Through these opportunities, students are able to learn how to collaborate and communicate with engineers from other areas. Engineering education can also cultivate students' ability of thinking critically, so that the students can decide what they should learn. Globalization has hidden the boundaries of the countries. It is the growth of international market spaces. Internet, air transportation, and communications have provided the means for globalization. Transnational companies have emerged as part of globalization. Outsourcing has replaced, in many cases, the job center in one location. For example, many outsourced jobs go to Asia. Outsourcing is growing exponentially, and contracts for all types of jobs are being won. How can engineering education prepare students for this reality? Engineering education can facilitate the following to prepare students. First, comprehension of cultural and ethnic differences that impact engineering design. Second, understanding of the importance of design because we must take into consideration more than one body frame. For example, when considering the design of the car interior, several human factors such as posture, border frames, and different body heights must be taken into account. Third, comprehension about the different cultural perceptions of numbers and illustrations. For example, the number 13 in the United States is considered unlucky, and in other countries such as in China, it is neutral. Taking another example, a dragon might be seen terrifying for some persons. In China, however, it is a symbol of luck and power. Even in the United States, different ethnicities might perceive it differently because of their cultural background. Fourth, engineering education can facilitate teamwork opportunities with diverse team members as a means to build skills for the globalized engineering industry. Rolling chimneys, melting glaciers. Not everyone accepts the Australian suggestion about turning off the light. Many of us may not even feel the need of building a sustainable world until... So how can we save more gas? We can become a hyperminer or buy a hybrid car. The first tactic commonly used by hyperminers is to control the speed. Speed higher or lower than 55 miles per hour will lead to lower efficiency. On the contrary, when a hybrid car runs at low speed, it runs entirely on the electric motor. Only when the car reaches a higher speed that the petrol engine kicks in. Another hypermining tactic is to avoid fuel-wasting stop-and-go driving. When we drive a hybrid car, however, during deceleration or braking, the electric generator collects energy from the wheel and creates electricity to charge the battery. While hypermining must require drivers to change their driving habits to save energy, sustainable engineering design achieves the same goal by instilling sustainability into the design process. So how can we equip engineering students with the concerns and abilities of designing sustainable engineering artifacts? First, the society must reach a common understanding of the importance of sustainability.
If you're just looking at it in your science program and then your school you have cars idling outside of the school and you have no recycling and you don't even have a connection to even the land maybe that the school is on, then that's not sustainability education. It needs to be more holistic than that.
Second, we must reconstruct the engineering curriculum to address sustainability problems.
The Pacific Spirit Project is an experiential-based learning model. What we do is we work with faculty to instill in them the values that will help guide them towards incorporating sustainability in their curriculum. Our belief is that each faculty member knows their subject matter the best. What we want to do is inspire them to ask hard questions about how their technical field relates to the issues and challenges of sustainability.
Third, we must develop more advanced infrastructure to support sustainable design. For example, as one of designing software, SolidWorks supports sustainable design in this way.
Let's say that you're a computer manufacturer and you want to evaluate the environmental impact of a new hard drive sled design. An easy-to-use interface will ask you information about your part, material, manufacturing, process, and region, and ultimately where the product will be used. Sustainability Express then queries an extensive database and calculates the design's environmental impact in 4 key areas: carbon emissions, energy consumed, and air and water contaminants. Graphical charts will tell you how each design parameter influences each area of impact.
For those sustainability problems that we have not yet been able to solve today, we wish future engineers to provide solutions very soon.